Hello everyone, my name is Kun. Today, me and my group are going to be doing an egg drop experiment. In this experiment, we will be focusing on three things, which are the difference in the landing force between the apparatus with the plastic bag parachute and the one without the parachute. The second thing that we will be focusing on is the calculation to find the acceleration and the force. And the last thing is not to crack the egg. Let's begin. So we did some research and found that most of the apparatus are made out of straws and tape. And the design of it should be able to protect the egg from how expensive the apparatus is. So even if the whole thing fall on the ground with the opposite side of the apparatus, the egg can still survive. We checked out Mark Roberts' video about egg drop and we decided to use his idea and make a few changes to make it even better, which I'm going to talk about it later. As said, straws and tape is one of the best thing to use because we can bend and stick them together easily, which we can make the apparatus wider. But stuff we need are straws, tape, a pair of scissors, and a glue gun. So first, we need 12 straws and pair them up into 6 pairs, and each pair should be longer than 40 centimeters. Then we cut more straws into 3 inches long bit. We need 8 of these in order to make an egg pyramid like inner protection. Lastly, glue the long straws along the sides of the pyramid and we ended up getting something like this. The reason why we replaced some of the tape part with a glue gun is because glue gun has an ability to make things stronger and we can customize how the glue gun goes very easily. Before we do the experiment, we measured the distance from the point we will drop the egg to the ground because all the information is going to be used in the calculation part. The equipment that we use to measure the distance is the tape measure. Sadly, the first attempt didn't go well, so we gotta go back and make it more stronger by inserting chopsticks into the straws and adding more hot glue. Turns out, it's actually better than the first attempt. We didn't crack the egg, which means that this is perfect. Then we added the plastic bag parachute and see the differences. We clearly see that the apparatus is falling down slower than the one without the parachute, which means that the landing force will less than the one without the parachute. As I mentioned the goals in the beginning, one of them is to calculate the acceleration and the landing force, so the formulas that we will be using is this, and this. So let's start off by calculating the apparatus without the parachute by using the velocity formula. We put the distance in, which is 4.93 meters, divide that by 0.88 seconds, which is the time. So the velocity is 5.6 meters per second. Now we can move on to the acceleration formula, which we divide the velocity by the time, so 5.6 meters per second divided by 0.88 seconds equals 6.36 meters per second squared. Finally, we can end this up with the force formula, which F equals to mass times acceleration, which will be 0.26 kilogram times with 6.36 meters per second squared, which equals to 1.65 newtons. Now we do the same thing with the one with the parachute. Start with the velocity formula, 4.93 meters divided by 1.54 seconds, which will get 3.2 meters per second. Put that in the acceleration formula, which will get 3.2 meters per second divided by 1.54 seconds, which will get 2.08 meters per second squared. Lastly, the force formula, times 0.27 kilogram with 2.08 meters per second squared, which will get 0.56 newtons. In conclusion, the apparatus without the parachute has an acceleration of 6.36 meters per second squared and a landing force of 1.65 newtons. The apparatus with the parachute has an acceleration of 2.08 meters per second squared and a landing force of 0.56 newtons, which clearly shows that the parachute greatly decreases the acceleration and the landing force due to the ability of air resistance. Since we have done all the goals now, it's time to say goodbye and thank you for watching our video.